Originally, I founded a Vicharak because I really love to build the hardware, right? If you even
Mm,
see the story, Vicharak keep, let's say, going behind. And we always
mm,
focus on the hardware most, and then rest of the stuff happens to next. So, due to the limitations that we have in India, how do we build the complex hardware? And then we make the global product out of here. That was our primary motto. And we started learning about electronics. We started learning about complex stuff of the electronics. And then we moved towards the computing ecosystems and all kind of part. So original idea of Vicharak was that we wanted to dig deeper into computing system, kind of computers that we use right now. But
okay.
a whole new market. Let's say if you are saying that there will be a robotics, there will be drones, there will be autonomous vehicles. They would
Mm,
require certain kind of newer kind of computer. Like we are not going to put laptops onto the robots, right? They'll be powered
mm,
by some kind of different kind of computers, and
okay.
that's what we wanted to start with initially. So we focused on edge computing industry where we'll build the computers for such kind of systems.
Mhm,
And
mhm,
how do we come up with more efficient, more let's say powerful in terms of speed processing, real time, and also we also make a sort of stuff where the people who are actually building their stuffs on top of us, we make it very easier for them. So if you'll if you would like me to ask that how Vicharak is going to let's say how people will perceive the technology that Vicharak is
mhm,
introducing,
mhm,
mostly about we are enabling the intelligent machines that will happen next. And through our expertise at the hardware, through our expertise at the software, through FPGA based systems, through non FPGA based systems, and kind of different versions of hardware we are introducing, we'll keep doing it. So we had a product called Vaaman, and
mhm,
initially our motto with the Vaaman was that we wanted to make FPGAs widely available to the consumer industry.
mhm,
And we figured out there is a Raspberry Pi, and people uses it, and there are only I think let's say out of 10,000 only one two people use the FPGA. So what are
mhm,
the
mhm,
problems with the FPGA? What are the challenges with the FPGAs? Because it's very cool technology, and I think everybody should use it and learn it. But due to the infrastructural cost, due to non-availability of the hardware with the consumer price focused, and due to the software that is not out there, it's very limited to the certain kind of people who are electrical engineers or electronics engineers. So our goal was
oh,
that we want to introduce FPGAs to the mass number of people,
mhm,
students, hobbies, academia, startups, education industry. And to do that, the pricing should be very low. So that's
mhm,
when we launched Vaaman, which is technically very, economically very cheaper,
mhm, mhm,
around 14,000 rupees compared to any other FPGA boards out there. But we
okay.
still feel a gap that for entry level people, it's very hard to enter with this price tag. And also with the kind of
Okay.
FPGA configuration we are introducing, uh, they don't want to enter it. So what we can do about it? And that's when we thought, let's start with the first step. Let's start with the very basics, where people will eventually dive deep into it, and then it can evolve to a more complex system. And that's when with the Shrike-lite and FPGA and CPU board, we have thought of introducing something which can enable everyone out there to just try on it, and slowly they can, let's say, climb the ladder that we are building with other products. So that's the whole idea about the Strike-lite. Like we want everyone to use FPGAs. We'll come up with more softwares, FPGA
Mhm,
kind of, let's say, examples and more integrations, which eventually it's called a reconfigurable computing ecosystem. And
mhm, mhm,
whatever we are doing, it will allow them to use it. When you move towards more complex system, the latency becomes a bottleneck because your
mhm, mhm,
current computing, let's say your microcontroller, is limited to a single or a dual core, and it runs certain, uh, let's say, cycles or instructions sequentially. So if you want to read certain sensors data, you'll have to interface with it through I2C, GPIOs, or somewhat like other peripherals. You need to wait for it to be answered, and then you'll process it, and you'll do something else, right? And it you want to do these things continuously. Now, what happens is you build a very small electronic system, and it may require to do some sort of stuff in parallel. And through
Okay.
due to the controllers are very limited to do the stuffs on the parallel, you'll feel the latencies issues. You want more powerful MC, or let's say you want to move from 100 megahertz to 400 megahertz kind of part, and that's when FPGAs are very helpful. So you can run multiple calculations in parallel. You can interface with the multiple sensors in parallel, leaving CPUs completely free to do the sort of stuff that you want to do, which should be the real-time computing itself. And it can allow you to even do the stuffs where not even with the three or more similar kind of products will get you the results. So you can interface, let's say, 4 ultrasonic sensors, and still CPU will become completely free. And that's not any kind of microcontroller would offer you. So you can think of it as a second brain of your hardware. So CPU will
Okay.
be the first main brain, and
Okay.
FPGA will do the second brain. But the whole idea is that it's not the same. It's completely different. It's built on top of very different architecture and the ideology that it will allow you to do more complex stuff which not CPUs will allow you to do. So it's and
Okay.
it really combines it, right? That's the whole Vicharak's idea, that we are fusing it. We are fusing both of them. It's just not that we are making an FPGA board. We are truly making a kind of MCU plus FPGA board, which can do your computation, which can do your sort of many embedded tasks that you really want to perform. And fusion that we as a Vicharak knows very well, because we have done it on the very complex level with the Vaaman. So it's like very easy for us to do in such kind of stuff that we want to enable with the people. Yeah, so a Shrike-lite is somewhat, let's say we consider it as a beginner product. So it has around 1000 lookup table. We are planning to launch more, let's say less complex than Vaaman, but more complex than Shrike-lite, which
Okay.
have around 15,000 lookup table, and it might cost you around 3,000 to 4,000 rupees. And then
Okay.
the stuff that with the Vaaman we have, which is more around 10,000 to 15,000 rupees range. So that's what I told you very earlier, that we'll build a full ladder for people to climb on top
Okay.
of different hardware. And we'll keep adding the complexity at the both sides, CPU and FPGA, so they can sort of more explore the field around it. So Shrike-lite is just the beginning. Once people will start playing with it and understanding and learning with it and building the stuff, we'll have more products which will allow them to do even more complex stuff. Right. So FPGAs are very primer goal of Vicharak, and that's when the Vaaman comes in. And what we wanted to do is that uh, Vaaman is sort of fusion of a very complex software, hardware, Gati and Periplex kind of very long and system level tools, and allows you to do certain stuffs on Linux, which not non FPGA board allows you to do. So if you are building a robots or drones, or it will require a very real time computing ecosystem, Vaaman is helpful for them. But if you just want to run a simple application with a single board computing stuff, right, somewhat like a Raspberry Pi, that's
Okay.
when Axon is something that you can choose. So Axon is more about upgrade versions of Raspberry Pi in terms of all kind of peripherals, speed, RAM, and the stuff.
Okay.
But if you want real time and specific stuffs that you want to really accelerate, and then FPGA based applications will be more helpful. It aligns with our vision of reconfigurability, right? So
Okay.
let's say if you want certain kind of applications and they need 10 UARTs. So what you will do, you'll have to use bridges, you'll have to use some kind of converters to transfer from the one protocol to another protocol.
Okay.
And it will blot up your system. Now, FPGAs, you can do it. With the FPGAs, you can build such kind of systems which take 10 UARTs in input, and then you can transfer to the your CPU part and you can process it. but it will take almost a year for any, even for the FPGA demo, it will take 3 to 4 months to do it. For non-FPGA people, it will take around, let's say, 1 year to do it. So
Mhm.
learning curve to do that, it's extremely hard. And what we have done is we have built a simple tool, Periplex, with JSON input, where you don't need to care about what FPGA architecture is, what FPGA
Mhm.
development is. You just write the 10 UART with the pins that you want, and in a backend, we regenerate
Okay.
the architecture, we resynthesize the FPGA, we program the FPGA, even the
Mhm.
Linux kernel. It tweaks the Linux kernel in a way that it becomes this new UART peripherals becomes available to your kernel itself
Okay.
and allows you to do your stuff. Like you want to interface through Python or a C++ program in a Linux, you'll be able to do
Mhm.
it very easily. And it's not static. You can put combinations. You are I to say SPI can or one wire or any single wire or sort of it's due to usages of FPGA. It will
Mhm.
allow you to even upgrade the peripherals that are not there right now. But in the future, let's say if we are introducing I3C,
Mhm.
through the simple upgrade command, you'll also can use the I3C to your system. So
Okay.
Periplex is somewhat like a whole newer version of reconfiguring your peripherals by your fingertips,
Okay.
and you don't need to explore any other hardware. And
Mhm.
even the lower versions of Vaaman that we'll introduce next will have Periplex support. So Gati is somewhat planned with the Vaaman and Vaaman 2 and upcoming series of it. Our original
Mhm.
goal was to show people that with FPGAs you can do both of the part. Periplex and Gati both runs on an FPGA and still can do the sort of stuff that you want to do. And that's no NVIDIA board or any other boards can do it. So
Mhm. Mhm.
with Gati you can build. So we are building an AI accelerator which will use your ONNX or somewhat like a PyTorch model, and
Mhm.
based on it, it will resynthesize the FPGA design and reprogram the FPGA, and we take care of the inference here, and then you can do sort of compute on top of FPGA. And the whole
Okay.
idea of Gati is that it reconfigures the FPGA accordingly to the need of model, which rarely happens into the current ecosystem. Like you have a static ASIC,
Mhm.
like a GPU or somewhat like a TPU from Google,
Mhm.
and you run your models based on instructions. Like you program the chip to perform some calculations.
Mhm.
In FPGA, you design your own chip based on the operators that you want to define, and it runs on a data flow style computing architecture. So, as I described earlier, that Vicharak is all in for reconfigurable computing startup. So we are
Mhm.
kind of interested into the core level of computing architecture, and this all range of products are just aligned with it. So Gati Periplex are it's a layer. Like you have a Vaaman at the hardware, and you have operating system, and then you have a Gati and Periplex at the application layer. Yeah, I think it's very tricky and it's extremely complex. It's not impossible,
Mhm.
and if you have certain, let's say, it's certain will, then you'll be able to do it. Because I
Mhm.
think compared to 10 years earlier, it's much easier. Now you can order the components through
Mhm.
mouse or a DGK, and you can get fabricated your PCBs through the JLC or many online vendors. So, sort of infrastructural problem is mostly solved. You are not worried about that part. You can find lots of knowledge and materials out there in the internet. So, as of now, it has become very easier. The funding problem stays same. I think most of the hardware startups I am familiar with are still struggling with the funding, and it's
Mhm.
because the general mindset of the Indian people and cultural mentality. But it will slowly improve, and I think there will be more people who are doing the hardware for sure. So we are very excited about launching Axon Mini, which is our modular mini computer. It has been become very popular recently, and
Okay.
it has a very unique concept where you can change your ports, right? Somewhat like a
Mhm.
framework laptop, and we are in the so we are first in the world to bring such kind of product. and also it's based on Qualcomm SoC. So
Okay.
both of them would align our goal for the more computing complex infrastructure. Then next is Shrike-lite and similar versions will be launched from us.
Mm-hmm.
We are planning to make a mass productions of Shrike-lite worldwide, and there are, I think, already a very good customer base that we have
Okay.
for Shrike-lite that we have shipped uh, outside of India. I think around 200 customers and around 40 countries of the people who have bought from us.
Mm-hmm.
So we'll expand our sales and allocate distributors to the various regions. And we also are excited about Vaaman 2 launch, where
Ah,
it will be, I think, world's most powerful CPU plus FPGA fusion in a
okay.
single board, and it can do sort of stuff which rarely any other computing ecosystem out there can do. So it's mostly from tiniest, let's say, tiniest robot
Okay.
to the
Mm-hmm.
complex robot. We'll have everything where you can use your some sort of stuff from us. Have Wi-Fi based FPGA board out there. So Strike-lite was
Okay.
RP2040 based, then we'll have ES32 S3 based FPGA board. So for some people,
Okay.
if you want to use IoT based applications, they can use it.
Mm-hmm.
Then you'll have somewhat like Linux and more, let's say as mentioned, more complex FPGA, around 15,000
Okay.
lookup table, and it will cost around 33,000 to 4,000 rupees, I think. And
Okay.
then there will be a lighter version of Vaaman. So that will be the kind of stuff will be.
Okay.